All right, so let's dig in. Thank you everyone for joining this session. We're going to talk about Smart on FHIR. And just to make sure everybody's got access to the slides, I've got a link up here which I'll also display on the first few slides, but it's bit.ly/smart-FHIR-tech. And that'll have the slides from this deck, as well as from a couple other presentations that we'll be doing on some related specifications over the course of the week. So I'm going to start off with these Smart on FHIR slides, the first link here. Quick introduction. I'm Josh Mandel. My day job is at Microsoft, but I've had the privilege and pleasure over the last 8 years to have been the chief architect for the Smart Health IT project, and it's still a major focus of my attention today. Everything I'm going to be showing you is based on open standards, open specifications, some open source reference implementations and sample apps, and I'm going to get to talk with you a little bit about that ecosystem that's been growing up. Quick introduction to the sort of problem that we're trying to solve with Smart. One way to say it is we've looked across the health ecosystem at organizations that are trying to adopt third-party apps in the course of their clinical workflow to try to give clinicians, patients, researchers tools for working with healthcare data in the context of their everyday jobs. And we commissioned a report last year with the CLASS organization. So in 2017, they did interviews with staff at many different kinds of clinical provider organizations, from large to small. And this was one quote that sort of highlighted the pain point that Smart aims to address. So the quote is from a physician talking about experience in his practice. It says, "We had this wonderful population health tool, but we couldn't get the EHR system to interface with that tool. So we had to enter all the information in by hand, and eventually we just gave up on this tool because we couldn't keep up with that process of entering data by hand." And that summarizes it pretty well. There's a ton of innovative work happening, but as long as it remains disconnected, it's very hard to take advantage of the value that those tools could provide, should provide. So our core focus in Smart is the following. And we started this work with a grant from the US federal government, from the Office of the National Coordinator for Health IT. We had a 4-year, $15 million grant between 2010 and 2015 to build out the set of core technology for this view. So on the one hand, we've got many different kinds of healthcare apps. These could be clinician-facing apps, patient-facing apps, tools for researchers, and they could be the kinds of things that you would integrate at the point of care, for giving you advice about how to take care of a given patient. They could be retrospective analytical apps to give you a sense of how your population is doing, or anything in between. And on the other side of this diagram, we've got many different kinds of clinical systems. It could be many different electronic health record products that are clinician-facing, could be researcher-facing data warehouses, or personal health record tools. And the key idea here is how can we integrate one app, write it once, and integrate it with as many of these different systems as is feasible. What would be the basic toolkit that we would need to do that? How do we decompose that problem of writing an app? What are the components of an app? And so what we said in Smart is there's 4 basic building blocks that an app developer needs in order to get this job done. So first of all is user experience integration. This is especially important for clinician-facing apps, where you want to be able to launch an app or a service from inside of the EHR workflow without having to quit what you've been doing and start from scratch by looking up a new patient record. And so that user experience integration, especially important on the clinical side. Second is security. So we'll talk about both authorization. How do you give apps access to do just the jobs they need to do without giving them more access than they require? And there's also a component of authentication, or single sign-on. How do we make it so that users can start working with a new app without having to go and create a new account and manage usernames and passwords for every app that they want to engage with? And then finally, critically, of course, is a set of APIs for working with clinical data, clean and standardized clinical data. And so everywhere possible here, we rely on open standards. Broadly speaking, on the security front, we rely on OAuth and the OpenID Connect standards. And on the clinical data front, of course, we rely on FHIR. And so we'll be talking through some of the value proposition and some of the tools that we offer for app developers to get started in this ecosystem. So just a little bit about why users and developers should care. So on the user side, if you think about what a clinician or what a patient gets out of a platform like this, the goal is really what we call substitutability. So SMART is an acronym. It stands for Substitutable Medical Apps and Reusable Technologies. And the goal here was to get a finer point on this notion of interoperability. So interoperability can mean many different things in different contexts. It could mean sharing data between systems. It could mean just having a shared record so you can look up where a patient has been seen. But what we are trying to get at in SMART is the idea that you should be able to run a clinical app on top of your data system And if you don't like it, or if a better one comes along, you should be able to swap out the old one and switch in the new one. That's this concept of substitutability. Just the way that on your mobile phone, you can use the calendar app that comes with your phone, but if you find a better calendar app that works for your needs, you can swap that calendar app in, and it still has access to the underlying database of events that you're scheduled to attend. So that's substitutability. And from the developer's perspective, what this really gives you is the ability to write an app once and run it in many kinds of environments. And I'll put an asterisk on this, especially when we're talking in the software development context. The promise of write once and run anywhere is always an overpromise. And so I won't try to sell you on that. But what I will sell you on is the idea of writing an app once and being able to tweak it only slightly and get a lot of leverage out of it. And that's already very powerful. So the idea is to lower the barrier to developing an app that can run in a lot of different places. And fundamentally, that changes the economics of writing an app. So for example, when I was at Boston Children's Hospital, a department, an individual clinician, would often have an idea for a tool they wish they could build. And every once in a while, they'd get together the resources to make something, to actually deploy that app in the hospital. But if you think about the resources it takes to build an app that you can deploy in just one place, it's pretty hard to justify doing a really polished job of it. So you've got a lot of research grade or sort of research quality applications that were sort of just close enough to working that you could deploy it, and a few people would use it and they'd really like it. But it would never make sense to take that to the next level of development and fit and finish and polish to be able to make a product that you could ship. It's simply too hard to ship it. So that's what we're trying to change with Smart, to say, actually, it makes sense to put in that work, develop the app to a level of polish that you can distribute it to many different places, whether it's as an open source app or whether it's through a business model where you try to monetize it. We want to sort of change the economics of developing those apps. And in that model, EHRs really become a platform. They take care of a lot of the hard details about working with health record data and working in the environment of a healthcare organization. Managing users, so whether that's clinicians or patient user accounts, handling core business logic and workflow and services, handling the compliance aspects of keeping audit logs and maintaining those certifications over time. And then you've got a platform that apps can plug into. So app developers get abstracted from a lot of those underlying platform details. I'm not going to spend a lot of time talking about what is FHIR here today. Given that we're at FHIR DevDays, I think folks have a pretty good concept, and we've got some good introductory materials here as well. But when I talk about this more generally, what I like to say is that FHIR provides you a contemporary sort of REST API for working with clinical data, and a set of models that people can more or less figure out how they work. It's an open specification. It's published so that anyone on the web can come and learn more about the details of how it works. I will say a couple more details about the OAuth specifications that we use. And in Smart, we define two main ways to start an app. We call those launch flows. And so one of them is what we call the EHR app launch. And the idea here is this is for a clinician-facing app that's going to run in the context of a session inside of a health record system. So there are many commercial and open source health record systems today that support this workflow for launching a Smart app. And the idea is if you've got a patient record open, if you've been seeing a patient at the point of care, and now you want to run an app on that patient record, the EHR app launch flow gives you a way to run that app embedded inside of the EHR so that the app knows about the context. It knows about who you are, it knows about which patient you're currently seeing, and it can just get started and show you the information that you care about right now. And basically the way that this works is there's a little back and forth dance between the EHR that you're working with and the application, which is launched inside of a browser context. So either a browser control on a desktop EHR or an inline frame on a web-based EHR. You can build the application as a web-based app, and as a developer, you know that your app is going to be embedded inside of an EHR where it needs to run. And there's this little back and forth dance that happens where the EHR opens your app on a particular page or on a particular path that tells you it's time to launch right now. And it sends along a little parameter called the launch parameter that your app will then use as it enters into this OAuth process. So there's a back and forth. The app then opens up a browser context back into the EHR to make sure that it can get what's called an access token. Sometimes that means showing a screen for the end user to approve this launch. It's typically not done as an interruptive step for a clinician-facing app. Typically, there's a policy that would be set up ahead of time. So every time a clinician goes to launch a growth chart app, they don't have to approve and say, yes, I want to share the data with the growth chart app. That's typically handled automatically behind the scenes. But especially for patient-facing apps, where an individual patient might be choosing which app they want to work with in their own data, it's typical to have an approval screen that gets displayed to the patient. So the patient can choose, yes, I understand what data are going to be shared with this app. I want to make that decision. And then once the approval is made, whether by policy or by an explicit choice, the app gets an access token, and it can use that access token for a fixed period of time to make FHIR API calls. And depending on whether the user approves it, that access token can also be refreshed to continue accessing data over a longer period of time. So that's the EHR launch flow. And one of the critical things that happens at the end of that process is, along with the access token, the app gets a list of what are called context parameters, which include things like which patient record is currently open in the EHR. Is there a banner already being displayed in the EHR with the patient's identifying information so that the app doesn't need to display that kind of information again if it would be redundant. And even some experimental parameters about styling, so things like what color scheme the EHR is using if the app wants to try to match that color scheme. Although there we're really pushing into the boundaries of what's likely to work well across different systems. So that's sort of an experimental feature. So that's the EHR launch. I mentioned this kind of approval that happens in that process, where a user or the system policies are expected to grant access to the app. In the smart specification, we say it's not all or nothing. We're not giving the app access to all the data about a patient. The app can ask for data specifically that it needs to do its job. So we have a language using what we call OAuth scopes that the app can use to request specifically which data it wants. And these scopes are based on FHIR resource types. So for example, if you're building an app that's doing immunization forecasting, your app might want access to a patient's basic demographics, and it might want a history of previous immunizations that a patient has had. And so in that case, your app could ask for a scope like this, patient/immunization.read. And it breaks down into 3 parts. First is this word patient here, which means for an app that's running on one patient at a time, the app only needs to get access to data in the context of that single patient. It doesn't need access to a whole population level. It doesn't need to access other patients, just the one that's in context in the EHR. The second one is the FHIR resource type. So in this example, it's an immunization. And the third one is either read or write. And in this case, if the app is just going to make a recommendation and display something on the screen, then read access is sort of good enough. So apps can start to use this scope language to request access to just the data that they need. So a simple app that's going to do a growth chart, for example, might need access to historical observations and some basic patient demographics, and that would be a read app. An app that was going to do something like electronic prescribing might need access to write medication orders, or I should say medication requests, if I'm updating to the latest version of FHIR resource definitions. And then a population health app that might be accessing data from more than one patient at a time might want to say, I want to access all the patient records that the current user, the clinician who's launching the app, would have access to. And so those would be scopes that start with the word user instead of starting with the word patient. So the app breaks down a list of the scopes that it wants, and then some explanation of those scopes is provided to the user. I want to highlight a limitation of this system as well. So it's powerful for apps to be able to say, here's what I need, and here's what I don't need. And it generally helps you to scope down access. But this scope language is pretty limited. So for example, when I ask for observations, because I want to do a growth chart app, I don't today have a way to say I only need access to height and weight and body mass index observations. All I can say is I need access to observations, which, as you'll know in FHIR, is actually a pretty broad category. It includes vital signs, it includes lab results, and so effectively you may be asking for more than you really need. And it's an area for future kind of design to ask, are there ways that we can be more fine-grained about the kinds of things that apps need at launch time? But in general, this has been a pretty pragmatic way to do it, and any server that understands what FHIR resources are can implement a model based on these resource-level scopes. So that's a little bit about what happens when you're launching an app, how an app asks for just the data that it wants. I want to switch gears and talk a bit about adoption, talk about some of the places where these specifications are being used today, and then show you some of the developer tools that we provide to help you get started building an app and testing it and deploying it. So one of the strongest forces behind these APIs was actually an initiative from the US federal government, which was the requirement in the Meaningful Use program that APIs be made available for patient-facing apps. So the US federal government basically said patients should be able to run the apps of their choice against their own health record data. And this sparked a pretty deep community discussion about how to do this in a standard way. The government didn't actually require that a standard be used here. They said, we're thinking about FHIR in the future. We think that's a good direction. But really, just any API will work as long as you document the API and make it available. So we could have been in a situation where 1,000 different health record vendors built 1,000 totally different APIs and independently published them. And that would have satisfied the letter of the law. But fortunately, a core group got together in something called the Argonaut Project, including many of the predominant health record vendors in the US, to say, how can we do this in a standard way? How can we profile FHIR and review the Smart on FHIR app launch specification to get common agreement on how to do these kinds of app launches and how to standardize those data profiles. So that's going back 3 or 4 years at this point. Those vendors came together in the Argonaut project, reviewed the SMART specification, sponsored an external security evaluation of that spec. And over time, the Argonaut group has taken on new projects each year, including a project in scheduling, a project in provider directories, and a project in clinical decision support hooks. Some projects this year, including one that we'll be talking about later, include a project in clinical notes and in bulk data access, so how to export data about a whole population of patients at once, as well as questionnaires. And we've been starting to see major health systems now in a position where they can run these apps. So Ricky Bloomfield, who's now at Apple, but was at Duke at the time, built out a system so they were able to run these smart apps inside of Duke on top of their Epic EHR. And Duke actually did this work before Epic had out-of-the-box support for the Smart on FHIR APIs. Today, this is much simpler for a provider organization to do because you don't have to go and build your own API servers the way that Ricky and his team did in 2015. This is just an out-of-the-box feature that you can get from Epic, from Cerner, from Allscripts, and from a growing list of electronic health record vendors that have support for these kinds of APIs. So I want to give you a sense of some of the developer-facing tools that we've provided. And one of them is really a way to advertise the apps that you've built, make it easier to discover what apps are out there. And the idea is this is a way that clinicians and patients and others can come and basically say, what could I be doing with my health data? What are some interesting ideas and tools that have been developed? And so the Smart App Gallery is a public resource. It's free to list your app. And it's vendor neutral, which is to say you could build an app that works across several different EHR systems, but you can list it in our gallery and give people a way to explore it and see where it runs. And I want to do a quick demo of this gallery. So if you go to apps.fhir.org or apps.smarthealthit.org, it was going to be super cool if this actually loaded. I'm going to be kind of sad. I don't know if it's a problem with the website or just whether I'm offline altogether. Oh, that's going to really help a lot. Not Smart Health IT, as we might have in Boston, but smarthealthit.org. Thank you for reading carefully. And so this is the gallery. It has a set of sort of featured apps that we list on the front page, but apps are categorized in a simple way according to sort of the main job that they do. I want to give you a quick sense of what a listing looks like, in particular so that I can show you one neat trick that the gallery does. So I'm going to show you an example of an application that does medication translations. This is built by a company that's called Polyglot. They were acquired by First Databank, I think last year. And these guys focus in language translations. So the basic problem they're trying to solve is if you've got a patient in your emergency department and you need to prescribe them some antibiotics, and that patient speaks Russian, it doesn't do a lot of good to send them home with English language instructions for their medications because they may not be able to follow those instructions. So they've built an app that can translate those instructions into something like 18 languages. That's the Medication app. And so the gallery provides a way for the developers to give a quick synopsis of what the app is and does, include some screenshots and some videos, as well as information about the version of FHIR that the app is compatible with, and information about which EHRs the app is available in today. So we'll talk a little bit about deployment. But today, many of the large EHRs have their own marketplaces or stores where users can go and deploy these apps. So in our gallery, if there's a way to deploy it inside of the Epic App Orchard or the Cerner App Gallery or the Athena Health store, you can go and click through and get access to this same app inside of your own vendor system. But the other cool thing that the gallery does is it provides this button here called Try App. And this is linked back to a couple of core services that we provide, including a sandbox environment with some sample data. So if you're developing an app and you figure out which patients it works with in our sandbox environment, this gives anybody a way to come with a simulated login screen. You can see the credentials here are pre-filled, so I don't actually have to type anything. But it's a simulated EHR environment that lets you then go ahead, pick a patient, and then it'll run the app on that patient. So in the case of this Medication app, what's going to happen is Medication will go through that OAuth process. I just approved it to get access to my records. And then it can do a FHIR API call to fetch a list of medication prescriptions for the current patient, which it displays here in this table. And then the core feature of this app is you can say, I've got my patient who's going to speak Russian, so I can go ahead and print a set of medication instructions in the language of my choice, in this case in Russian, and they'll give me this PDF that I can print out that's going to have Russian language instructions for all the medications that a given patient is supposed to take. And it includes some interesting things like a pictographic view of the times of day that a patient is supposed to take each medication. So that's an example of how you can launch an app from inside of our app gallery environment and give developers a way to showcase what they've built. I want to give a couple of forward pointers to sort of related specifications that work well with Smart, or that my team on the Smart project has been building out, especially for things that we're going to be talking about later this week. So one is doing FHIR for population level data. In particular, being able to export data about a whole population at once to be able to move it from a clinical system, for example, to a data analytics environment. So we're going to do a talk on Friday, which is the FHIR bulk data talk. So if you're interested in that front, that's a good session to attend. And the other one is decision support that's integrated into the clinical workflow. This is a project called CDS Hooks, or Clinical Decision Support Hooks. And the idea here is to be able to incorporate external advice directly into the workflow as the clinicians are doing things like writing prescriptions or writing orders on a patient in the process of a hospitalization. So that's the CDS Hook session, which is also going to be running this Friday. And if that's interesting, we'll be talking about how that spec works and how it plays well with the Smart on FHIR specifications. And then an example of a use case, which is sharing data with researchers, a project that I've been working on at Harvard Medical School called Sync for Science, where the goal is to say, how do we lean on all these specifications to help patients access their own data and share them with an app of their choice, which in this case could be a research study. So we've been doing a lot of good work to get consistent implementation of these APIs, and one use case is letting patients share their own data with researchers. Next up, I want to talk about some of the open source tools and services that we've been building out on the Smart team to give developers an easy way to get started building and testing these kinds of apps. And so central to this is our Sandbox environment, which includes what we call the Smart App Launcher. That's at launch.smarthealthit.org. And I'll give you a quick taste of what that looks like and the kinds of things you can do with the app launcher. So the idea of this tool is if you are building an app and you need to configure your app to run against a FHIR server, you want to be able to test out many different things. One thing you want to do is figure out which patients are going to work well with your app inside of a set of sample data that we have in our sandbox. Another kind of thing that you can do is be able to show this app to people either in the context of an EHR or a personal health record system. And so this tool lets you try out each of the different launch types. We talked a lot about the EHR launch for those apps that run in the context of a clinical environment. But the other main launch type is what we call a standalone launch. So instead of starting from inside of an EHR session, you might start from tapping on an app's icon on your mobile device home screen. And from there, you want to reach out and connect to the EHR. So that's what we call the standalone launch. And inside of the Smart App Launcher, you can say which kind of app you want to test out, which kind of launch you want to test out with your app. So it might be a provider-facing standalone launch, or a patient-facing standalone launch, or this provider-facing EHR launch. And so you can say the basics of what you want to do. You can say which version of FHIR you want to work with, and today that means FHIR R2 or FHIR R3. And you can go and pick a set of patients that might work well with your app. So there's a way to go and choose from our sandbox of patients. You can browse through patient data, do some basic searches based on demographics and the kinds of sample data that are available. And you can say, OK, I'm going to pick this patient as one that I think is going to work well with my app. And populate it into the launcher. So you go and you choose all these kinds of details inside of the launcher, and once you've chosen them, you get what's called a launch URL. So based on the details that you've picked, this launcher is going to generate for you a different FHIR-based service URL. And this is basically just a stateless design kind of trick where we pack all the details that you just chose in those drop-down lists into this URL, and you can tell your app, hey, here's the FHIR server URL to launch against. And all the choices that you made are baked into that URL, so you can simulate many different kinds of FHIR servers running on different versions with different default patients and different launch flows. And you can even simulate errors as well. So if you want to figure out how your app is going to respond to an error in the token request step of that OAuth launch flow, you can say, yep, I want to simulate that error. And then you'll get an updated FHIR server URL that's always going to simulate that error for you. So using this launcher, you can cause our Sandbox server to act in many different ways, and then you can test them each out with the app that you're building. So that's a quick view of what the launcher is and how it works. And I want to show you this in the context of a very simple demonstration app. So this is the glucose sample app. This demo is going to use a tool called glitch.com, which is a web-hosted kind of IDE development environment that will spin up a server and let you host, in this case, just a simple static web application. You could do the exact same thing by opening up a terminal on your local machine and running like Python-M simple HTTP server or any other technique you like to host a web app, but especially for demos where people don't want to go and install software on their own computer, this glitch.com thing works pretty nicely. So in this glitch.com app, you can follow the link that I just showed to my glitch app, which is called exciting-firefly. That was a randomly generated name, but I was fairly pleased that the word fire showed up in it. You can come and take this app and fork it and tweak it to your own interests. But what I wanted to show you in this were the basic parts of a simple smart app. So in this case, we'll be looking at a standalone launch application. And so we provide a JavaScript library, which you don't have to use to build a smart app, but it's a pretty convenient way to get started. And if you use our JavaScript library, then you can just call this FHIR.OAuth2.authorize function. So in our standalone app, as soon as you go to the app web page, it's going to start the authorization process without waiting for you to click a button or do anything. It's just going to jump right into it as soon as this script tag runs. And in this case, in the standalone launch, you need to know which EHR you're launching against. In this case, we're going to do it against the Sandbox environment that I just showed you. So I pasted in one of those launch URLs from the previous step, but you could paste in a tweaked version of that launch URL if you wanted to make it work slightly differently. So that's under the hood. The standalone launch is going to start off that launch flow. And what I'll show you is the hosted web page. That's excitingfirefly.glitch.me. I'll show you what that looks like if I try it out as a user. So I'm just going to navigate to that standalone.html page. As soon as I get there, it's going to load my library, and then it's going to send me over to sign in to the EHR. So in a standalone launch, you go from the app to the EHR to sign in. And in this case, all the credentials are pre-filled for me because it's the simple demo environment. And then I'll be given, in this case, a question. Do you want to authorize access to these data? This app is asking for access to observations and demographics on the current patient record. And in this case, I'm going to say, yes, I approve that. In our launcher, you can configure our sample EHR to either show this screen or not show it. In this case, I wanted to get across to you all the point that there can be a patient-facing step. So I said, yep, please show me that screen. But if really what you're trying to do is skip ahead to your app, you can also configure it to skip that step. And then what the app does is it makes a couple of simple FHIR API calls to fetch some recent hemoglobin A1C values and make a plot out of them. And I won't go over the details of how that works, but I will show you where that plotting code lives. It's very straightforward and simple. It's just embedded in this index.html page. There's a function that's going to get those observations, doing a query based on the LOINC code for hemoglobin A1C, and then there's a simple function to iterate over them and generate a set of X and Y values that are going to go into that plot. So the whole thing is about 50 lines of code to do that query and use a library called Plotly to make the plot. So that's a simple demo, but you can start to get the sense for how this standalone launch workflow works, how you can integrate an app with the Sandbox environment that we host at smarthealthit.org, and how you can take a simple working demo and tweak it for yourself by using some of these online tools. I also want to describe a little bit about the FHIR libraries that are available. So we have a library in JavaScript, which I showed you in that demonstration app, but also a library in Python. And there are community libraries in a number of other languages for working with these APIs. And so if you're getting started writing a FHIR application and you want to do the Smart on FHIR integration thing, it's worth looking around and seeing what libraries are available, because starting from a maintained library can be a good way to get a more reliable app, but also to save time on the development front. We also have a number of open source sample apps which are listed at apps.smarthealthit.org. So anybody can go and list an app there. We list a few ourselves that we developed at Boston Children's Hospital, including a growth chart app and including a blood pressure app that calculates blood pressure percentiles to give you a sense of whether a child's blood pressure is high or low or normal for their age and height. So there's a good set of examples that you can get started from on that front, and the source code for those apps is available on GitHub. I do want to say a few things about the broader landscape of building and testing these kinds of smart apps. So I showed you this infrastructure with the Smart App Gallery and the Smart App Sandbox with our launcher, which is a good place to get started with a rich set of sample data, but there's also a sandbox environment from HSPC, the Healthcare Services Platform Consortium, where you can go and get your own FHIR server that you can write resources to and maintain them over time. It's a great resource, as well as sandboxes from some of the major EHR vendors. So Epic and Cerner and Allscripts each host a sandbox environment where you can register apps and try it out against those commercial EHR products. Graham Grieve maintains Smart on FHIR support within his Health Intersections sample FHIR server. So there's a lot of places where you can go and test out these apps, and I really only highlighted one. But we think that a good pattern as you're getting started is very early days, pick one and integrate until you've got something that works. But as soon as something works even a little bit, it's worth going and registering, especially with some of the commercial EHR sandbox environments, if you're interested in targeting those EHRs, so you can start to get a sense for what's supported in those environments as well. In our own sandbox, for the Smart Sandbox, we have a combination of some de-identified longitudinal records, as well as some synthetic records that have been generated from the Cynthia project, and then a small number of patient-reported outcomes data that come from some NHS surveys. So we try to provide a kind of rich set that spans the set of clinical data that are commonly available from inside of EHR systems today. And in many ways, our focus has been on the data set that's what Meaningful Use calls the common clinical data set, the kinds of data that are required inside of the US health IT environment for patient access, but also becoming the common core of what's well standardized inside of across multiple EHR systems, I should say. So I want to say a couple things about our documentation site, and there's a link to docs.smarthealthit.org here, including more details about the sample data that we host inside of our own sandbox. And I'm also very proud to say, including an almost broken link. So if you go to authorization and click on the Smart App Authorization Guide, as of yesterday, there's no content here. Why is there no content here? Because it's moved to an official publication from HL7. We finally got this out the door. This started off as a set of specifications that we built as a research project at Harvard, and it's now a draft standard from HL7. So you can click through to hl7.org/FHIR to get the Smart App Launch Guide, and that's officially published as a 1.0 version as of yesterday. So that's pretty exciting for me, and it goes through all the details of the actual specification, how those OAuth processes work, how the launch context and all those parameters can be used to launch an app inside of those health record systems. A couple of links here to the other tools that I showed you, including the Smart App Launcher, and as well as a very detailed tutorial that the team at Cerner has put together for a previous DevDays. And so this includes a detailed write-up, which we're linking to on the Cerner engineering blog. And I also have a hosted version of this tutorial in that Glitch platform. If you want to try it out, you can click through these links to run, in this case, a patient-facing launch. So I'm going to pause there and see if there are any questions or details that we could go into more about, please.
Yeah, any news on the R4 spec? I mean, you mentioned STU3 as
Yes, so the question is about FHIR R4. Is there any news in terms of support? So a few things to say on that front. So one is if you go through the details of our officially published specification for the Smart App Launch Framework, this is designed to be FHIR version agnostic. And there's a little asterisk on this because some of the details about how we publish conformance data have changed between FHIR DSTU2 and FHIR STU3. But the idea is that now that the capability statement is a resource that's going to be locked in and consistent over time, there's no longer a dependency between the way that we do this Smart App Launch and any particular version of FHIR. So this spec is compatible with FHIR DSTU2, STU3, and will be compatible with R4. In terms of our sandbox environments, like the Smart Sandbox, for example, we don't yet have R4 support, but it's something that we're planning to do as a follow-on once the official publication is out. Other questions or comments? Yeah, please.
So I had some students writing an app recently, and what they wanted to do was link. So I had some students writing an app this semester just finished, and they wanted to link from their app back into the EHR somewhere. Is there any movement on the ability to do that in a kind of substitutable way?
Yeah, so the question is about linking from an app back into the EHR. And I mean, there's a few aspects of that word linking that we can explore. All right, so one read on that word is linking would mean inserting data back into the EHR. That's not what you mean. Navigation linking. Yeah, great. So in other words, a user is interacting with the app, and once they're done interacting with that app, there's some navigation step that they're going to take in the EHR. and you want to support them taking that step without having to basically display some text on the screen saying, hey, user, why don't you go and click on this button in your EHR now? You want to actually be able to do it for them. So yes, we've had some progress on this front. In a draft specification, we just set up a backroom session. It's going to be me and Janet Campbell from Epic talking about the smart web messaging specification that starts to get at that question. So how do we set up a richer interaction between the app that's running embedded in the EHR and be able to send messages back and forth, including things like navigation hints. And that's going to be Friday. I don't know what time it's slotted into yet. Yeah, please.
Will that apply to mobile native apps as well?
Will it apply to mobile native apps? Out of scope for the initial design, which is to say we've focused on post-message based communications between an EHR and an embedded application, but it's worth talking in more detail about what a mobile native app interface should look like on that front. We didn't go there first, but I think it's worth digging into. Yeah, please.
Every medical practitioner in Switzerland a server, smart and FHIR server for its own. And we started implementation already, but I would be really interested in what's your favorite means when it comes to patient authentication? Because as far as you can see, you have as an app user already, you got the token already. But when it comes to patient authentication, what is the preferred method?
So if I understand the question right, this is for an individual patient to authenticate to access their own data. Is that right?
What tokens do you provide a patient as a practitioner with for them to log in from their home? Is there something like one-time based tokens, or what is the preferred method? So
in general, the problem that we've tried to address in SMART is the authorization problem of saying what data an app is allowed to get. We don't try to address the issue of how a given user signs into the EHR system. So we help, if you've got a way to sign into the EHR system, we help you leverage that to sign into an app. But there are many different ways to handle sign into an EHR system. And I don't think there's a one-size-fits-all solution on that front. I will say that, personally, I've been pretty excited about some of the development on open standards for authentication, including things like WebAuth. But figuring out the right set of authentication strategies, where to deploy additional factors, where to do probabilistic checking to identify unusual activities. This is a pretty rich area for development, and we didn't see a way to try to standardize that. Time for one more question, if someone's got in the corner, please.
Yeah, my question is, can the Angular framework be used to write smart apps, or is there a showstopper doing it?
So can the Angular framework be used? I mean, the short answer is yes, absolutely. You can build this using any client or server-side framework you like. You may or may not find that that is an easy thing to do with the smart libraries that we publish. And depending on the version of Angular that you're using, you may or may not want to start from our open source client app. But absolutely, as far as the framework is concerned, it's just REST API calls and redirects in the browser.
Thanks.
All right, I think we are about at time. Thanks, guys, very much, and I'll be around the whole week. Happy to talk offline.